In this active elements we are having independent. In this independent we are having ideal voltage source and current source, ideal voltage source and current source, and practical voltage source and practical current source. So from this definitely you will get an objective bits, and the example of the unilateral element and active elements are dash voltage source and current source, B R comma L comma C, C diode, D none of the above. Active elements are voltage source and current source. And in this active elements, what is the internal resistance of ideal voltage source? What is the internal resistance of ideal current source? And internal resistance of practical voltage source, internal resistance of the practical current source. These are all important objective bits. So what is meant by independent? So independent sources, if you are taking the independent voltage source, independent means the sources are represented with circle. So independent voltage source means the voltage source is represented with plus and minus. So what is the definition of a ideal voltage source? So what is the definition of ideal voltage source? So ideal voltage source which delivers the energy, which is independent of current flows through the load. Independent sources are represented with circle, voltage sources are represented with plus and minus. And what is the definition of the ideal voltage source means which delivers the energy to the load, which is independent of the current flows through the load. Suppose I want to apply, see here, I am having a 5 volts and the load resistance is 1 ohm. So load resistance is represented with R subscript L, and now what is the current which is flowing now? What is the current which is flowing here? I is equal to V by R. So this is Ohm's law. V is directly proportional to I, where I is equal to V by R. So 5 by 1, that should be equal to 5 amperes. Entire 5 amperes is flowing through the load. So this is plus and minus. Always the current flows from higher potential to lower potential. So higher potential is represented with plus and the lower potential is represented with minus. And 5 into 1, so what is the voltage now? 5 volts. So I have a 5 rupees in my pocket and the entire 5 rupees is utilized by the load. But think that if a government releases 100 crores for a particular project, that 100 crores is effectively utilized for the project? No. Because some loss will be there. So that's why we are going for the practical voltage source. So practical voltage source, which is practical voltage source, delivers the energy. Yes, which is also represented with circle with plus and minus. And here it is load here. And which delivers the energy which is dependent on current flows through the load. This resistance is called the source resistance and the supply voltage is Vs, and the current which is flowing through load is called the IL, and the voltage which is applied across the load is VL here, and here also it is VL. Now what is VL? VL here, apply KVL to this loop, Kirchhoff's voltage law. Otherwise, if you don't know the Kirchhoff's voltage law, but I have a 5 rupees, entire 5 rupees is given to load, means VL is equal to what? VL is equal to Vs. So even if you vary here, even if you vary the current, load current, is there any change? No change in the load voltage because it is independent. So load current will be, means you are connecting a more number of loads, but there is no change. So that is an ideal case. Ideal case is not existing in the practical world, because ideal means ideal only. So suppose a person getting a 100% result, 100% pass percentage in one of the university, that is not at all possible. Maybe it is possible 100% pass percentage in one class or in one subject. That is not possible in all the subjects. So similarly, same way, some drop will be takes place. What is the drop is called the, see, apply KVL to this loop. Here I want to cover the KVL. So otherwise, I have a 5 rupees in my pocket, 5 rupees in my pocket, and 1 rupee is drop here, 1 rupee is drop, and the remaining 4 rupees will be applied across the load. And is this case is better, or I have a 5 rupees, only 0.1 rupee is the loss, and the remaining 4.9 volts is utilized by the load. Our aim is to the most voltage, more voltage which is utilized by the load. The supply voltage, whatever the supply voltage is there, so 95% or 99% is utilized by the load, then only it will be benefited. So that's why, so this case is not better and this case is better. So in order to get the 0.1 volts or less drop, the resistance value of the internal voltage source or ideal voltage source is 0, but coming to the practical voltage source is less value. RS is greater than 0 ohms. This is very, very important. Coming to here, and the resistance value is equal to 0 here. If the resistance value is equal to 0, see, resistance 0 means it is a short circuit. This is very, very important. Resistance 0 means voltage is 0. Voltage 0 means short circuited here. So let us say this terminal is A and B. This is called the short circuit properties. What is properties called? The short circuit properties. Short circuit properties means resistance is 0, voltage is 0, and the current value is high. Current value is high. See, it is 0 means the drop across I into the resistance value is 0. I into 0. I into 0 means what is the voltage value? 0. Coming to here, so if a less value of drop means the resistance value, RS value should be designed with a low value. Designed with a low value. So what is the internal resistance of ideal voltage source is 0. Internal resistance of ideal voltage is 0. Internal resistance of practical voltage source is greater than 0 but lower value. Greater than 0 but lower value. So you have to design the voltage source is like that. Suppose if you take a battery, phone battery also, even if you charge for 100%, if you kept it in phone, so let us assume the Android phone and background apps are not running. Even though if it is not running, after 1 day, the battery will be discharges. So battery acts as a voltage source. Battery acts as a voltage source. But even though if it is 100% charged, after 4 to 5 hours, 1% will be reduces. Why? Because the internal resistance is present. If you take a generator also, so generator will generate the electricity, and generator winding is there. Winding is made up of copper. Winding is made up of copper. Copper has low value of resistance. Copper has a low value of resistance. If a resistance value is less, then copper losses is also less. Copper losses are also less. What is my copper loss, sir? I square R. I square R losses is also less. Okay, so this is the difference between the ideal voltage source and practical voltage source. Ideal voltage source internal resistance is 0 and the practical voltage source internal resistance is greater than 0. But so voltage source in series with the RS. Voltage source in series with the RS means internal resistance is connected. Internal resistance is connected in series with the voltage source. Then only the drop will be produces, and that drop will be should be minimum. And so Vs is equal to see what is the current which is flowing now, IL. So IL into RS plus VL. IL into RS plus VL. So otherwise you can apply the KVL to this loop. Always the current flows from higher potential to lower potential. Assume the loop current direction either clockwise. So this is one loop. So if it is a closed path means it is consisting of a one closed loop. Here also it is a one loop only. See, if it is flowing in a clockwise direction means always the current flows from higher potential to lower potential. So current enters into the positive terminal. Current enters into the positive terminal can be treated as positive, means plus. And what is the current here? IL. And what is the resistance? IL into RS is called the voltage. And the current enters into the positive terminal, yes, plus VL. But here coming to here, minus Vs is equal to 0. Check this equation is correct or not. Vs is equal to VL plus IL into RS. I have a 5 rupees in my pocket. That 5 rupees is given. In that 5 rupees, only 0.1 rupee is a drop. The remaining 4.9 is utilized effectively. Okay, so VL, what is the VL now? Vs minus IL into RS. So, if IL is equal to 0, sir, if IL is equal to 0 and the RS value is 1 ohm, now what is the VL? VL is equal to Vs, so then Vs is equal to 5 volts here supply, so 5 volts, Vs is equal to 5 volts. And if IL value will be increases, if IL increases, so IL is increases to 2 amperes. What is the VL now? VL is equal to Vs is 5 minus 2 into 1, that should be equal to 3 volts. See, observe that if IL increases, load current increases, whatever the load voltage value will be decreases. If IL increases, the load voltage, so VL is equal to Vs and the load voltage will be decreases. So generally for understanding purpose, as I am taking 1 ohm, but it is less than 1 ohm only, 0.1 ohm or 0.2 ohms like that. The internal resistance is very, very small. Okay, this is my